What are the absolute zero temperature, the freezing point, and boiling point in the three major temperature scales? One way of interpreting this question is it is complete to the chart that I have here on the whiteboard where I have the freezing and boiling points. I still have Romer up there, and I don't think that's one of the three major temperature scales, so maybe we don't have to do that one. But if we could complete the column that I've added here on the left for absolute zero, that's what we're being asked to do. And I think one of them I can do easily. Well, I already wrote up here minus 273.15 as the experimentally established point for absolute zero in Celsius. I could go through a process. I could either like take the formula from the key concepts page and solve for the temperature in Fahrenheit and plug in minus 273.15 to find what the number should be here for Fahrenheit. For the Romer scale, I don't have such a formula, so I'd probably have to do some kind of setup where I come up with a formula by labeling one as an x and a y and finding a slope and using point slope form as we've done in previous examples. Kelvin I think I can do because we know that there's 100 degrees Celsius between freezing and boiling. There's 100 Kelvin between freezing and boiling. And so it makes sense that Kelvin that's the one that actually is zero at absolute zero. And I've argued that makes it the real physical unit of temperature on a better kind of like basis than the other temperature scales. I think to save us some time, since I don't necessarily want to do the math to find this one here, is let's go ahead and just look in the slide and see what answer is actually there. And you can see, so the one question mark, it's arrayed a little bit differently here because for this table, I put the three temperature scales at the top, and so the columns correspond to the temperatures at the respectively absolute zero, freezing point, and boiling point. And so the answer I would have put in here for the question mark for Fahrenheit is apparently minus 459.4 degrees. So if you like, you can do that on your own and see if you get the correct result, but don't feel like you have to, I would say. And then the 273 here, I actually, in this table, I rounded off the 0.15, whereas I left it in on the whiteboard, which is maybe an interesting thing to look at, because sometimes people will just round that off to 273. If three significant figures is good enough, maybe that's okay. To have been more correct, though, I probably should have included, since that 273.15 I think has a fairly exact definition. Maybe it's changed a little bit with the new redefinition. I'm gonna say look that up because I'm actually not 100% sure as I record this here, but I know it used to definitely be more exactly defined. But maybe there's some more digits here. Look that up, I'll say. But this kind of summarizes again the three major temperature scales, including now absolute zero in addition to the freezing and boiling points of water.